Children, it is a continuation of the exercise of the chapter motion. Now you take the fifth question. A driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brakes slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graphs for the two cars. Which of the two cars traveled further after the brakes were applied here? Here we have to find out which of the two cars traveled further after the brakes were applied. Here the speed is given in kilometer per hour. So you must convert that into meter per second. Now you take, let us consider the first car is A and the second car is B. So you take for the car A means that is the first car. So it is given that speed is equals to what it is given, 50 km per hour. That is equals to 50 into 1000 per hour means that is 60 minutes into 60 seconds. It becomes 60 into 60. Then you will get, here it is 0 0 cancels, 0 0 cancels, and 2 3s are 2 26 it is. Again 2 3s are 2 13s are. Then it becomes 130 by 9 it is. Divide 130 by 9, that is 130 divided by 9. 9 ones are 9. So it becomes 13 minus 9 is 4. Take 0. Then it is 9 4s are 36. Again that is the remainder is 4. So take the point, put the 0. 9 4s are 36. Again 4. So here 4 is recurring. You write it 14 minus 4 ms to the power of minus 1 it is. 14 minus 4 ms to the power of minus 1. Then here you take the time and distance here. Time and speed you take. Here speed and it is time. So at the time 0, the speed was 14.4 ms to the power of minus 1. And when the brakes are applied, it comes to rest after 5 seconds. After 5 seconds. So here that is for the first car. That is for the first car. Next you take the second car here. So for the car A, when the time is 0, the speed is 14.4 ms to the power of minus 1. And after the apply of brake, it comes to rest after 5 seconds. So after 5 seconds, its speed is 0. That is for the first car here. Next you take the for car B. For car B, here speed is there. Here driving at 3 km per hour means that is the initial speed. Speed is equals to 3 km per hour. That is equals to 3 into 1000 by 60 into 60. So here it becomes 3 ones are 3 twos are 2 ones are 2 5 you will get 5 by 6 ms to the power of minus. If you want to convert that into the decimal form, it becomes point, put 0 here, 6 8 is 48, 2 50 minus 48 is 2, so here put 0, then 6 3 is 18, so approximately it is equals to 0.83, so you write that is equals to 0.83 ms to the power of minus 1. Here again you take speed and time chart here, speed and time. When the time is 0, that is the initial speed, the speed is here 0.83 ms to the power of minus 1. After 10 seconds, here when the brake is applied, after 10 seconds it comes to rest. So here after 10 seconds speed becomes 0. So here this is the chart here. Now you come to the graph. Here you take the time in seconds on the x-axis and velocity, that is the speed, on the y-axis. Take it is speed here. Speed in ms to the power of minus 1. First you draw the graph for car A. So when the time is 0, its speed is 14.4 ms to the power of minus 1. So it will be approximately here. You mark here. And after 5 seconds, 5 means here, after 5 seconds it comes to rest, it comes to 0 speed. So here these are the 2 points. Then you can join these 2 points here. This is the graph for A. This is for car A. Next you take the second car B. Here when the time is 0, its speed is 0.83. So you take 0.83 means here only it is less than 1. So you take, that is here it is. And when the time is 10 seconds, it comes to rest here. It comes to rest. So here the graph will be here. So this is for car B. For car B. So you got the 2 graphs. One is the graph for car A and the other one is the graph for car B. Come to the question number 6. The figure 8.11 of your textbook shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following questions. And here A, which of the 3 is traveling the fastest? B, are all 3 ever at the same point on the road? How far has C travelled when B passes A? How far has B travelled by the time it passes C? Now the answer for the first question A, which of the three is traveling the fastest? See the slope of the graph here. The object B starts from the speed 0 and reaches the maximum distance here. That is, you know that the slope of this graph is maximum. The object for which slope of speed time graph is maximum will have maximum speed, that will travel with fastest. Here the object B slope is maximum, so it is traveling the fastest. So which of the three is traveling the fastest? The object B is traveling the fastest. So for the first question, the answer is the object B is traveling fastest because the slope of this object is maximum. The slope of object B is maximum. That is, slope of the object B is maximum. That is, slope of the speed distance, speed time is here maximum for B. Therefore, object B is traveling fastest. Second question, are all three ever at the same point on the road? Here, all the three graphs do not meet at a point here. Here, all the three objects will ever be at the same point on the road if the speed time graph intersect each other at any point. Here, all the three graphs do not intersect each other, so these three will never be at the same point on the road. So here, you know that two graphs are intersecting, but here there is no point at which all the three intersect. Therefore, what you can say, all three objects are not on the same point here. So what you can write? So for the question B, you write the answer. Here all the three graphs, here all the three graphs do not intersect each other. Do not intersect each other. Therefore, three objects will never be at three objects will never be at same point on the road. Next question, C here. How far C has travelled when B passes A? See here. Find the point at which B passes A, the graph B and graph A. Graph B and graph A. Here B passes A, that is the point P here. This is the point at which B passes A. At that time, here you know that is here, if you find this one, that becomes near about 10. So if you find it, it will be near about 9.6 you can get here. And you know that is here there is a graph C. So that becomes 9.6 minus 2. 9.6 minus 2 graph is here. That is 9.6 minus 2 means 7.6 kilometer you can write. So here when B passes A, when B passes A, distance travelled by C, distance travelled by C is equals to, so what we have to write, 9.6, it is approximately near about 10. So you take 9.6 minus 2, that is 7.6 kilometer, it is 7.6 kilometer. Next the question D. How far has B travelled by the time it passes C? Here distance travelled by B by the time it passes C. Here B and C, where B and C meets here. This is the graph B and this is the graph C. So they meet at this point. So how much time distance it travels? So you will get that is 6 kilometer. So you take distance travelled by B, distance travelled by B by the time it passes C, by the time it passes C is equals to how much it is? That is 6 kilometer. Now you take the 7th question. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? Here the ball is dropped from height, that is it starts from rest. So its initial velocity is 0 as it is dropped from the height. So here you take u is equals to 0 because the ball is dropped from height. And you know that what is the height of the ball when it was dropped? So it was at 20 meter height. And the acceleration is here. Acceleration is, that is A. A is nothing but here acceleration due to gravity. You can write A or G here. A is equals to G, that is equals to 10 ms to the power of minus 2. And here what you have to find out? Here the final velocity we must be find out. And with what velocity will it strike the ground? After what time will it strike the ground? That you have to find out. So you write V is equals to question mark and also T is equals to question mark. So here you know that the equation which is having here H means that is nothing but S. U is equals to 0. Height is nothing but distance travelled by the ball here. And acceleration is A, that is also we will take that as a acceleration due to gravity G, that is 10 ms to the power of minus 2. What velocity will it strike the ground means we have to find out. V is equals to question mark. And at what time will it strike the ground? That is T is equals to question mark. So here the equation which is having U, S and A and T. You know that the equation is here S is equals to ut plus half at square, that you can take. Now here you will get T here. Here you can't get the V, but you will get T here. So it becomes S is here 20 meter and U is 0. 0 into T is not given. So half into A is here, that is 10 ms to the power of minus 2 into T square you take, into T square, that becomes 20 meter is equals to 0 plus 2 ones are 2 5s are 5 ms to the power of minus 2, that is T square. So here interchange LHS and RHS. Before that 20 meter is equals to, it becomes 5 ms to the power of minus 2 into T square. Now you interchange LHS and RHS, that becomes 5 ms to the power of minus 2 T square is equals to 20 m. Then T square is equals to, it becomes 20 m by 5 ms to the power of minus 2. So T square it becomes, cancels here, 5 ones are 5 fours are. So it is 4 by s to the power of minus 2. Big T square is equals to 4s square it becomes. Therefore T is equals to, you know that if you take root on both the sides, it becomes T square becomes T and 2s it is. That is by taking like this way, whole root of T square, whole root of 4s square, you will get T is equals to 2s. So you can say that after 2 seconds it strikes the ground. Next here, get V here. So to get V, you write V is equals to U plus AT, because here T you got, A is given, U is also given, that is 0. Then here you write V is equals to U is 0 plus A is, that is 10 given here, 10 ms to the power of minus 2 into T is 2 second here. Then V is equals to 10 2s are 20 m s to the power of minus 2 into s to the power of 1 it becomes. So V is equals to 20 ms to the power of minus 1 it is, because s to the power of minus 2, s to the power of 1 is equals to s to the power of minus 2 plus 1, that is equals to s to the power of minus 1. So you got the answer for the question, that is velocity, with what velocity will it strike the ground, means with velocity 20 meter per second. With velocity 20 meter per second it strikes the ground. It strikes the ground. And next, at what time, after what time will it strike the ground? It will strike after, you got it, after 2 seconds. After 2 seconds it will strike the ground.